Now, how to visualize it, how to visualize our data. This is related to how to choose graphic forms to represent our data. Should I use a bar graph? Should I use a map? Should I use a table? Should I use this? Should I use that? And the answer to that question is always, there are really no rules. All there is reasoning. What you need to think about whenever designing a visualization is that if you want to communicate clearly, because visualization can be used for different purposes, right? There are people who use visualization to create art, which is completely legitimate and it is fantastic, and I absolutely love it. But when it comes to do the type of visualization that I do, which has a very, very clear communicational purpose, right? We need to pay attention to the goals of the visualization, what it is that we want to say with that particular visualization. And according to that goal, then we can make choices in terms of how to encode the data, how to represent the data. Quick example. This is a chart that was designed by the European Commission a few years ago. Doesn't really matter what it represents, but it represents migration towards Greece. Of all the migrants who arrived to Greece in 2016, which countries these migrants came from, right? Because it's a pie chart showing the total and then the portions of that total. At the time, the creators of this chart, they asked, do you think that this is a good chart or a bad chart? And my answer to that question is always, I don't know if it is good or bad, if I don't know what purpose you had in mind when you designed this visualization. So I use it as an opportunity to explain reasoning in visualization. I said, well, let's suppose that I am doing this graphic. If the purpose of the graphic is to show that nearly half of these migrants came from Syria and the other half came from other countries, then this is fine. The only change that I would make would be to emphasize that message even more by coloring Syria with one color and all the other countries with a completely different color. Syria with bright blue and then all the other countries with one shade of gray, for instance, just to emphasize that half versus half. And it will be completely appropriate, right? A pie chart works well if it is isolated. If one of the segments is much bigger than the others, a pie chart may be appropriate to show that. However, let's suppose that is not the case. Let's suppose that the purpose of the visualization is not to show half versus half. Let's suppose that it is to compare these countries to each other. You want to be able to compare the proportion of migrants who arrived from Iraq to the proportion of migrants who arrived from Pakistan. You want to compare Pakistan to Afghanistan, Afghanistan to Algeria. The pie chart is not great for that. It forces you, if you want to compare those segments, you need to squint and then use your fingers to estimate the sizes of those segments. So pie charts are not great for comparison. We have a lot of empirical evidence showing that. They may have other purposes, but certain accurate comparison is not one of them. And what if, for instance, the purpose of your visualization is not to show half versus half, is not to compare the countries, is to show where these countries are? Well, then you will need a map, right? You will need to represent those countries on a map, right? So based on that little exercise, I represented this very small, this very tiny data set in 3 different ways. And there may be other ways to represent this data, right? This is just to make the point that neither of these representations of data is right or wrong. Things in visualization are 99% of the time never right or wrong. They are better or worse, depending on what we want to achieve, depending on all the reasoning process that I have been describing so far. So the reason why I'm saying this is that one of the most common mistakes among beginners when for example, in my classes, I sometimes do this exercise. I give my students a data set in which everything adds up to 100%. And I say, design a data visualization with data that adds up to 100%. And I don't say anything else. I know that a substantial portion of them will come back to class with a pie chart, because a pie chart is a traditional way to represent a 100% and the portions too of that 100%. I said, why did you design a pie chart? And the answer is usually, well, because everything adds up to 100%. I said, well, but that is not a good reason, because you're not thinking about what the communicational purpose of the graphic is. Do you want me to compare? Do you want me to see parts of a whole? What it is that you want to show? Based on that, you need to choose your graphic form. And I also know that if I give students a data set that contains geographic variables, such as countries or counties, any unit of geographical distribution, and I said, design a data visualization, some students will come back to class with a map. And then I ask, why is this a map? And I say, well, because there are countries in the data set. Well, no, Perhaps a map is not the solution. Perhaps the best way to represent the data is a bar graph. It depends on what you want to achieve. Do you want me to see where the countries are? Then the map is good. Or do you want me to see some sort of geographic pattern in the data? Such as, for instance, it might happen that the closer these countries are to Greece, the more migrants from those countries go to Greece. That's a pattern worth highlighting. That's a geographic pattern, in which case a map will be appropriate. But if we want to compare the countries to each other, the map is not great. A bar chart may be much better. But that doesn't mean that the bar chart is better than the map. They are just different. They fulfill different purposes. So this very, very, very simple explanation of the reasoning process that I usually follow when creating a visualization, when choosing graphic forms for a visualization that intends to communicate, leads me to a couple of recommendations of things that you can look into yourself from this point on. The Data Visualization Catalog is a chart chooser. It's a website in which you can read about the most common types of forms of visualization design. And then the Visual Vocabulary is a large poster put together by the Financial Times in which they organize the most common types of visualizations according to the main purpose that those visualization types may help you fulfill. Do you want to show spatial patterns? Well, you have all these options down here, many more, but these are the most common ones. Do you want to show parts of a whole? Well, we have all these options. Do you want to compare the magnitudes of different things? Well, we have all these options over here. Now that we have these options, that we have narrowed down our choices to these options, let's discuss which one of them may be more appropriate.